In this video, we are going to talk about empirical probability. But as we have done in other videos, we're going to start with a little bit of investigation of a problem, and then we'll come back and put in the definitions and other math notation. We will start off first with the following problem. Mrs. Gallus was a star basketball player in high school, where she was an impressive 80% free throw shooter. The first question says, in your own words, what does it mean to be an 80% free throw shooter? So think about that for a minute. Maybe pause the video and write something down. So I paused the video and I came up with each free throw has an 80% chance of going in the basket. Your answer may be similar or different than mine. The next question says, if Mrs. Gallus takes 100 shots, how many do you expect she will make, and is this guaranteed? So take a moment, pause the video, write something down. Since she makes 80% of the shots, 80% of 100 would be 80 shots. Then the question says, is this guaranteed? It may be more or less than 80 shots. For this next problem, we are going to use an applet on our computer and have Mrs. Gallus virtually shoot 100 free throws. And we'll use this table to keep track of it. Now, a couple notes. If you have this in PDF form, you should be able to click on this link. However, if you have downloaded it into a note-taking app, or if you have it in paper, this link doesn't always work. So what we're going to do is open up a browser. And if you read the URL, it says Stats Medic. That's what we need, Stats Medic. And then we need the applet. So I'm going to type Stats Medic applet, just as a Google search. And this Staplets one, I believe, is their older version. So I'm actually looking for the one that says Stats Medic. And here are all the applets from this website. The directions say to choose the law of large numbers applet. So I'll just scroll down here to the law of large numbers applets under concepts. And here we have Mrs. Gallus and we have the basketball hoop. Now, going back to the directions, it says use the applet to shoot 100 free throws and use the table to keep track of the results. All right, let's see how this works. We have a little button that says shoot, and the first time she makes it. So on my table, I'm going to write out of one shot, we made one, and 1 divided by 1, that will be 100%. Then I'm going to do this a few more times. So the second shot, they made it. Third shot, she made it. Fourth shot, she made it. Fifth shot, she made it. So out of 2 shots, there 2 were made. This will still be 100%. Same thing with the 3, 4, and 5. These are all 100%. And now the table bumps up to 10. And I'll just shoot it 5 more times. All right, then I need to go to 15. And I'll continue on in this manner until the entire table is filled out. Now I would like you to pause the video and you can finish out this table. Then sketch the graph of those 100 shots and comment on what you notice. That's question 5. And then in question 6, it says, of those 100 shots, did Mrs. Gallus make exactly 80 free throws? And comment on why or why not that happened. So I paused the video also, and here are the results I got. And now you can take some time to sketch the graph and then comment on what you notice. Here's my graph, and what I'm noticing is that we are getting all different percentages, but they are getting closer and closer to that 80%. And if you look there's a line on the graph showing that 80%. The next question says, in the 100 shots, did Mrs. Gallus make exactly 80 free throws? Now, yours may look different than mine. On mine, you'll see that out of that 100 free throws, 85 were made successfully. So every sample is going to be different. So this is a good place to document that. Then question 7 says, based on the results of the applet, what does the probability of 80% mean? Well, this means that after many free throws, the percent approaches 80%. If yours isn't as close to the 80%, similar to mine, I'm a little bit off, let's go ahead and just add some more free throws in there. So let's do another 50. And as you see now, we are at 84%. If we do another 50, we're at 82%. Another thing that I've seen happen is that some of the graphs, we have parts where it goes under this 80%, which is totally normal. I'm just adding another 50 shots, and as you see, I'm at 82%. And now at 300 shots, I'm at 80.3%. So as we keep doing this, we will see that the average is 80%. Now that we have gone through this exploration, let's go ahead and put in some vocabulary and then define those things. The first thing we want to define is this type of experiment. This type of probability experiment is empirical probability. The thing that makes empirical probability different from theoretical probability, which we did in our previous video, is that for empirical probability, we need some data. How did Mrs. Gallus figure out that she has 80% free throws? Well, she had to first start gathering data. She probably did lots and lots of free throw shots, and that was her percentage. She didn't just know it, which is different than theoretical probability, which we did in the last video, where we had the die. When we roll the die, we already know the probability. We don't actually need to do the experiment. Going back to question 5, it says, what do we notice about the graph? Well, we noticed that the numbers were all different. We could see that there's a different percentage for each and every shot. But as we do more, we're getting closer to that 80%. Well, this is the law of large numbers. And we learned that in the last section, where it says if we do something many, many times, the proportion of desired outcomes will approach the theoretical probability. And that's what's happening here. We have a series of free throw shots that maybe at the beginning we don't know the percentage. But as we do it many, many times, we're able to figure out her true free throw shooting percentage. The last thing that we need to define is empirical probability. This is going to be the observed frequency of the event all over the total number of outcomes. Now, just a quick note, you may notice that this definition is very similar to the definition that we had for theoretical probability. So theoretical probability is the number of outcomes in an event. But empirical probability is going to be the observed frequency of the event. So something that we have to find data on. That's the difference between theoretical, based on math theory, so we're dealing with dice or other similar things like that, versus empirical probability, in which we are relying on data or historical information. And that's empirical probability.